Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Sarah Alspaugh, and I will be your webinar host, coming to you from Cincinnati, Ohio, here in the U.S. I'd like to welcome you to today's webinar, our topic, Providing Rapid and Intelligent Diagrams for Electrical Wiring Design. And I would like to welcome and introduce our speaker today, Mike Ashbaugh. Mike joined Siemens Digital Industry Software from Mentor in 2019 to support business development of the Solid Edge portfolio. He has a BS in electrical engineering as well as a BS in physics. Mike has over 30 years of professional experience. His primary focus has been virtual prototyping, supporting PCB simulation and analysis solutions within the Hyperlinks family. These tools address today's design complexities and challenges in the disciplines of signal integrity, power integrity, EMI, and 3D EM analysis. Welcome, Mike. We're very excited to have you here today. I'm going to go ahead and make you presenter here, and you can bring yourself off of mute.
So Sarah, thank you very much for that introduction, and welcome everyone to this webinar. Glad you could take the time to join us today. The agenda I have for you is I'm going to talk about the industry trends for electrical systems and then mention some industry-leading technology that Siemens did acquire from Mentor Graphics. And that's a nice segue into the product that we're focusing on today for this intelligent diagramming, and that's solid edge wiring design. So I'm going to do an overview in the presentation and then get into the software itself in the demonstration. I want to spend most of our time together today in the software. And then we'll have a few minutes at the end to answer some of the questions that you submit to Sarah. So the industry trend is there's an increasing demand for connected and customizable products, often called smart connected products. And in a survey, which was recently taken, we're seeing the results of that. When engineering design teams were asked, what is the value of your electrical systems now in the products? And 71% came back and said that that value is increasing. And 37% said that value was increasing significantly. So the electronic components is really playing a big part moving forward in these customizable products. So the designs are becoming more complex, and that's creating some challenges for these companies and the teams. And here's more data to support that. What is the impact of this additional design complexity? Well, it puts pressure on the market, the time to market. Lost revenue, easy for the projects to overrun with these complexities, and there's a lot more design inefficiencies, which can also affect the quality and optimization. So this is what's happening in the industry. The companies feel it. The design engineer teams feel it, but yet the electronics is so important in what they do. They're recognizing that that's how they differentiate their products, by adding this electronics into their products and systems. Design complexity has many forms. One of them is the compliance, which we're showing on the left side of the screen here. Lots of rules and regulations that need to be followed. There's industry standards, there's safety standards, governance, various regulations. So they need to manage all of this design complexity and be able to show transparently that we're following these guidelines and requirements, in addition to make sure that the product performs on time as expected. So they really have a challenge with that. So I wanted to start with this because what does this boil down to? The idea here is that the traditional methods, they're just not working for them anymore. So we need new processes, new methods, and new software to help us with these design complexities. So I'm going to show you some images here to give you a good idea what are the type of products that are a good fit for solid edge wiring design that need that intelligent wiring diagram. These are products that require harnesses. So somewhere in the assembly here, there's a series of harnesses that connect all of these electrical devices, these smart connected devices. Needs to work right the first time, and they need to follow all of those compliance constraints that we saw on the previous page. So think of the products that require these harnesses, and they are driven by wire diagrams and the details on those diagrams. Another good application is in the industrial machinery industry. Here we're showing a control panel or panel design. With this application, the end result is not so much a harness. However, having a wiring diagram that depicts the components wired together that go in the control box is critical for them. Lots of sheets of components and elements on that drawing needs to be managed. So this is a very good fit for those looking for a wiring diagram application. The industry technology that I mentioned in 2017, Siemens acquired Mentor Graphics, picked up lots of products and technology. For our discussion today, we want to talk about the product called Capital. And that's an enterprise solution for electrical system design and manufacturing harnesses. Been around a long time, lots of users, very mature software, and is targeted for the automobile and aerospace industry. That software has been leveraged and targeted now for the small and medium-sized businesses and therefore the solid edge user. The name of the product for the solid edge users is called the Solid Edge Wiring and Harness Design. So this is not new software, but it's leveraging that platform that came from Capital. So it's just easier to configure and implement out of the box, used for the smaller to medium-sized businesses so they get access to this technology to do their electrical systems design. So again, to reiterate, it's not new software, but the name is new. Solid Edge Wiring and Harness Design. Now, where does this fit? When we say Solid Edge, we're really talking about an entire portfolio, not just MCAD. And over the last few years, over 55 products have been added to this portfolio. We're looking at this image here, and it shows the 7 pillars of which we kind of organize the technology in this portfolio. For today, we're talking about the electrical design pillar, and that's where we found this Capital technology called Solid Edge Wiring and Harness Design. So that gives you a real good understanding of where the software came from and how it's now being enabled for the small and medium-sized companies. So before I talk about the new methodology and what we can do with the software, let's have a little reminder of what's the traditional approach. Many people are still designing this way today. The person on the right would be the person doing our electrical systems design. She's working on her wiring design, her schematic. And the gentleman on the left, he's a mechanical team colleague of ours. And you can see that break in the image is depicting that. They work in separate isolated environment, they're using different software, and they don't really communicate about their design data because it's very manual in nature, it's very tedious, time consuming, and when that's the case, what happens is they only share the information when they really need to. Maybe they've done a lot of the bulk of their work and now they're going to share it with their colleague. And what happens when we do that is that we find out we have some issues or some constraints, and now we struggle to meet that timing and our schedules and try to figure out what's the best solution. Well, this gets more complicated if the electrical system software on the right-hand side is more of a drafting tool, and it doesn't have intelligence built into it. Changes are much slower. Any bill of material that needs to be generated from that has to be manually created, and that's very, very time consuming. So we want to change that, and that's really the opportunity. So there is a better way to enable this communication as well as help with efficiencies by using the right application. Instead of using Visio and PowerPoint or something like that, let's use an intelligent wiring diagram application. So there's been software that's written for a better way. These are screenshots of Solid Edge Wiring and Harness Design. So we're going to bring those two environments together so we get that bidirectional communication, so the electrical systems team and the mechanical team communicate effectively from the very beginning of their design and continue that process. So I'm going to introduce the software modules for you for the solid edge wiring and harness design. Here on the left, we see solid edge wiring design and solid edge harness design. The wiring design is the environment where the users select from a provided electrical parts library shown on the image, where they select symbols and parts and wire up devices on their schematic. As they're doing that, they can do things like simulation, and there'll be a design rule checker to make sure that this is coming together nicely. If a customer is doing harness design, you can tightly couple our harness design with that, where the connectivity from wiring design can get synchronized into the harness design environment. Don't have to re-enter anything, you know it's correct. And then in harness design, we add the physical pieces that we need to develop the harness, and we can generate the appropriate outputs. On the MCAD side, shown on the right, that would be solid edge MCAD. And what's important there is where it says electrical routing. That's the piece of that MCAD environment that allows us to route wires in the assembly, but more importantly, to exchange the information from the electrical systems tools. So solid edge MCAD on the right can exchange information back and forth between wiring design and harness design. And I'm going to show that to you in my demonstration here today. So those are the software modules when we think of solid edge wiring and harness design. You'll probably hear me say this again throughout the presentation, but solid edge wiring design and harness design can be run standalone. So if you don't need to integrate with your MCAD, many customers operate it that way. If you're only doing wiring diagrams, you can just work with solid edge wiring design. So in my demonstration, I'm going to show you, the value of these intelligent diagrams. What do you get? What do we mean by that? And one of the important aspects of the software is this electrical parts library. I'm going to talk a little bit more about it, but that's really key to this intelligent application. You'll see that we have things like styling. What styling means is that we can set up standards so your graphics and the diagrams will look the same no matter who on the team is actually creating that wiring diagram. Font sizes, off-sheet references, title blocks, all that, so so we can communicate as a team and it's easy to read and follow up. We also have design rule checks, and what that means is the application, as you're capturing the diagrams, there's electronic checks going on in the background to make sure we're not violating some type of electrical issues. And I'll give you examples of several of those in the coming slide here. Also, what's included with solid edge wiring design is simulation. So in your circuitry, you can look at that, run a simulation, and see if it's actually functioning correctly. For example, moving switches in different positions. Is the circuitry behaving like I intended it to? But we can do more than that, is we can also look at the current and voltage readings of the signal going through the wire. That helps us with sizing of fuses and wires to make sure we're optimizing our design. Well, this really comes in important because remember the competition here. We're trying to optimize our products. They have more electronics in it. We want to keep the cost down. We need to meet the time deadlines. Having tools to help us do this with the efficiency is going to help alleviate some of those challenges that we're seeing. And we know there's more and more electronics every day in each of these products. For the electrical parts library, there's a starter library that comes with the product when you install it. And it now has over 4,000 symbols and parts, and it continues to build. This is where you manage your components. And what's key in here is there's a relationship to all the parts. For example, you have devices in your library and they have associated connectors, and those connectors have cavity information, and there's information about what terminals go into the cavities and what wires can go into the terminals. So this is how we get automation with the tool helping us make sure all this is put together because we're pulling the information from this electrical parts library. And we have design rule checks to make sure that that information is lining up. Help us catch those issues that we may have from the beginning and not waiting to the end. The design rule checks as they run, they come in 4 different categories. It could be an appearance check and something like that. Maybe the pins are not on the grid or the pins are overlapping conductors, for example. The connectivity checks that are going on. Maybe we have connectors or devices that are left unconnected. Or maybe we have a wire that's not terminated at one end. And when the schematic sheets get very large, that's a real big help for us. Library consistency is a good one, making sure that we don't have any cavity count mismatches. What we're showing at the bottom of this particular slide, this is a result of the report right in the application. And the line highlighted in blue, there's an error there, and it indicates that the wire is a mismatch for the cavity that we have set up to. So it's not a good fit, it's an issue. And the red text that's showing there, if we click on that, that will take us right to where this error message is in our design. Again, very helpful as we're trying to capture this design, get our design done. Here's an example of the circuit simulation. If you look at the circuit, the green wires are indicating that we have signal flowing through that. The cyan color is indicating no current. So here we can look at the function, right? We have the switches in a specific position. We could move them around and then see, is that circuitry functionally as expected, as designed? So that's one element of the simulation. But we can also look at the signal strength. And you're seeing on the image to the right-hand side, there's a graphic that comes up that shows you here's the current that's flowing through that wire, and it allows us to ask the question, is this wire diameter the right size? Based on all the constraints that we're trying to meet, you know, the mechanical team has their constraints and the electrical team has theirs as well. So that's the simulation built into every seat of the solid edge wiring design. Now I want to talk a little bit about the data flow so you can understand, you know, how can we, or in which way do we send the data, and also bring up what we call the connected mode. So the connected mode is what we use at Siemens to describe the ability of sending data bidirectionally between the electrical systems tool and the mechanical tool. So I'm going to highlight that here. So what I'm showing here is the electrical parts library. We're pulling and building up our wiring schematics. As we have information, we want to share that with the mechanical colleagues. We do that with the connected mode to the solid edge MCAD. And to do that, we need the solid edge electrical routing piece in the MCAD. Once in the MCAD environment, those engineers would maybe bundle the wires together, route them through their assembly, and now the electrical team needs that updated information. Have the wire lengths changed based on initial assumptions? That information is sent back automatically via this connected mode. So I'm going to show you that at the end of my demo, this connected mode, so you can see it's easy to set up, right? And if it's easy to exchange information, the design teams will do it. And we're getting that new methodology, the ability to co-design together. What I'm going to focus on in the demonstration, though, are the features and functions inside solid edge wiring design that we're looking at right now. But I'm going to continue and show the remainder of the suite so you have the bigger picture, and maybe some other webinar will dig deeper into some of these other things. The solid edge harness design now, see the big arrow between the two of them. Solid edge wiring design can share the connectivity information to the harness design, so we don't have to recapture anything. The term we use for that is synchronization. Then in harness design, the user would add the physical pieces they need to develop that harness. And one more comment about connected mode. Some customers, users, they'd like to take the harness information from solid edge MCAD and send that to the harness design application. That's called 2D flattening. So that's another use if someone wanted to do that, to use the connected mode. So this is the big picture, how data flows, and it enables that true co-design that will really help us meet these design challenges that we're learned about. So let me get into the demonstration and show you solid edge wiring design. So on my screen now you see the product, solid edge wiring and harness design. And what I'm going to start with is I'm just going to bring up a project so I can walk you through a project so you can see how designs are organized, how the information is organized, and then show you what the outputs are of a project. And then I'll go on and create a simple little design for you and simulate it. So I'm going to open up a project here called Electrical Systems. When I open that up on the top left-hand corner, we're looking at the project browser. And in this project, the subfolders are individual designs. And I have 6 designs here, starting with analysis at the top, wiring at the bottom. These designs can be either harness designs or wiring designs, all in the same software. I'm going to expand the one that's actually a harness design and double-click and bring that up for you just so you can see that. This is actually a harness design that was driven by a wiring design, and you can see the details of the cavity content on the connector and the additional physical pieces that would be used if you were doing harness designs. But we'll save that for another webinar. And I'm going to close this and now bring up a wiring design. This wiring design here has 10 sheets. I'm going to double click to bring up this one. So I have my content on the right hand side, and now you notice below the project browser is the design browser. And this gives me a nice snapshot of the content that's in the design. So wherever there's a plus, I can open it up and see the content. Now if I select a device in the drawing, it highlights that device in the design browser. So it's really easy for me to find that. The drawing also supports middle mouse wheel and strokes, where you hold down the cursor and draw. That's real helpful in some of these advanced drawing packages to navigate around. I select this symbol here, it highlights there as well. Right now I'm toggling my design view to show me only the contents of this active sheet. If I toggle this down here, it's going to show me all of the content in the entire design. What's nice about that is I'm looking through here and I would say I'd like to find this particular device here. Where is that? And I hit zoom to that, and it takes me exactly to that device in my design. This happens to be on sheet 3. And I can make changes here in the drawing by doing right mouse button property. I can change all the properties here. You're going to see this dialog box more and more in my demo. But I can do the same thing here over in the design browser. So you can change names, change properties, and things like that. Real powerful to navigate and find the content in your design. I mentioned like cross references, for example, in styling. What we're showing here, this is a wire, and I can look at the properties of that particular wire. The name of it here, it's got a color, and so, and eventually we would add a library part to it in this field here. But what I want to point out here is notice that this wire has some off-sheet references. So I know where else I can find this particular wire. It gives the sheet number, the sheet name, and then at the very end, it shows us what quadrant we can find that in the drawing. This is an example of styling that your team gets to set up. So you get to set the ideas like what font do you want to use? What's the offset from the wire end do you want to place this text? What details do you want in this? You get to pick that based on your company standards for efficiencies. And that way, all the designs would look the same. And we set all of this information in what's called style sets. And the tool makes this real easy for us. If I select an item, do right mouse button, hit style, set edit style, it's going to take me to the area in the style set that this would be set. Here's the style set. There's lots to choose from because there's a lot of different types of contents and elements. But I come in here and I select the name, and now I can look at the switches and details of what makes that style set look like the way it does. So that's a real important part of the tool here. All this intelligence that's built in. Now I want to talk a little bit about some of the outputs that we can export from a project. Let me just minimize this. And I'm going to begin with the PDF. That's pretty common. Under the File, Print to File, I can actually set the scope of this PDF that I'm going to write out. I could do all of the sheets in the entire project or just make it based upon a design or a diagram. We support multiple formats, and we're going to do PDF, but we support DXF, CGM, SVG. Let's go with PDF. And there's other settings in here, is like what is the convention of the file name you'd like to have that be, and there's other configuration in here as well. Let me just click OK and run that. And now that's generated in the output window. I can double click and bring up that PDF. And now we're looking at the results of that. Here we have 10 pages which we could navigate through. You see all the details in here. If I look and expand my bookmark, I get the same view that I had in the application itself. So this is real nice for customers that have to do field maintenance or want to share the design content with some colleagues, some downstream processes, for example. And it's very common that you might want to do a search on a wire name and it'll jump around to the pages that it can find that. So it really has a good use for that as well. Two other tabs before I then move on in the demo here. Under the drawing, we have several drawing lists that we can create: diagram, device, and wire. Let me just pick one here. It's on my cursor and I just place it anywhere on the drawing. Maybe I want to place some of these tables on another schematic sheet in the design. But this is a dynamic list showing us the diagrams in the design here. And it's dynamic, so if I go in here and I say I want to edit the name of this drawing, and I just put a 2 at the end of that, it automatically updates that view for me so I can see that. That went from me. And I want to show another one here, device list. It's a little bit larger. And it gets pretty large, right? But you can decide where you want to put that device list and wire list. Also, the workflow. Under the reports, we have a number of standard reports that are included. And I could pick one of these, design wire list, view the report, comes up in HTML, and then I have the ability to save that off, either in HTML or PDF. And if you find that your team needs a different format of some kind, you can go under the build and build a custom report. So that's kind of the overview of the project. You know, it's important to be able to get this information out of your design without doing any manual effort. All the details are captured in this intelligent wiring diagram, and the outputs are automatic. So let me show you an example of creating a new design, a simple circuit, and then we'll run a simulation. So right mouse button, new wiring design, I give it a name. Notice the red text in there. I already have a design called My Design, so I need to make it unique. So the tool is prompting me to make sure that I do that. And I got some settings in here to automatically create that first diagram. And when I do that, now I even have the title block. So this would be our company title block. If I zoom in here, here's more, part of the process and methodology that you get to select from. Put in your company logo. What do you want your title blocks to look like? What kind of properties do you want to have in there? And these are automatically put in there. The name of the diagram, it'll count the sheets for you, so you can look at sheet 4 of 50 or whatever you have, the date, who created this, who authored it, maybe it's been reviewed. So you really have a lot that you can do, and that's all part of this intelligent drawing tool. Notice in my design browser here, the tool automatically created those subfolders for me, but I don't have any plus signs because I don't have any content in there. So I'm going to put down about 4 components and run a simulation for you. Also, this is the time that I can show you how we query for symbols and parts in this electrical parts library. I'm going to use both of these. So under the symbols, a couple different ways to do this. I'm looking at the libraries that are available, and I can just navigate in here for a particular battery. I select a device, and I can see the graphic here, and maybe I want to use the single one instead. Double click, place that onto the schematic. There's another way to do this by using a filter. So I can type in switch, and then it shows me all of the places where I can find a switch, and I look for the one that I want, and I pick it, and then I put it down in the schematic. Do the same thing with a lamp, and then we'll add some grounds. So real quickly, again, I'm querying my symbols library. I could also do the parts library as well. So put that ground down. I can also copy that by Control-C, and then I can follow the symbol over there and place that down there. Now if I show you the design browser, you can see that I now have content in there for my devices. It also cross-probes. So I can select the device here, and it highlights it in here. So let me change the names of these devices real quickly. That'll be updated in the design browser. Double click, it brings up the property box. Call that the battery, the switch, the lamp, and now it updated those there. So all we need to do now is run some wires. So a couple different ways to do that. But what I want to show here is a couple things. Is when we run the wire, double click to end the wires automatically get routed for us. And that's a setting that you can toggle down at the bottom here. Sometimes you want to direct the direction and the path of the wire, and you don't want it to have the machine do that for you. But again, this is the intelligence built into the software. It knows what a wire is and how it needs to behave. And we see the names on all the wires, right? It's following some styling section that says don't put the wire name there unless it exceeds a certain length, so that's what it's doing. And then we look under the conductors here, and here's where we see our wires. And when we put down a wire, it's using the default properties of the wire there. So with this down, I'm really ready to simulate. I can hit my analysis and then start the simulation. Pretty simple little circuit. But you may recall from the presentation that the cyan color means that we don't have any current going through that. And we can toggle the switch here because the switch is open. We can toggle that down here to close it, and then we get the green. Right? We can do the same thing in the graphics itself. I want to show you the current reading. We would change to numeric simulation, wait for the green, and then just hold our cursor over there, and now we get the current reading in there. So the users could go in, change the wire diameters, see if they're getting the performance that they want, and they can do that. This is a pretty simple little example. I have another circuit that's a little more detailed than that, which works for us as well. Here's that circuit, same thing. What's nice, you don't need to do any modifications to the circuitry. It's ready to go and simulate. Some simulators, you'd have to recapture the circuitry and then simulate it, then go back into your original application. So again, same thing here. We can toggle the switches and look at the performance of that. I also mentioned the design rule check. That's a tab down here at the bottom. And I put an error in here on intentionally. This is telling us that we have a wire that's not terminated, and if I just click on that, it'll take me to wherever that is in the design. And what I did here was I put that on a separate page, just kind of isolated out there. So again, the tool's helping us catch these things before we go further down the road. So with that, I want to show devices. And devices are used when they're really flexible. I've showed you when we're using symbols, when we're using parts. If we look at devices, these are helpful when you're drawing and capturing your schematic, right? And you don't have the symbol or the part built yet. And so I can come up here and say, I just want to put down a device, and I'll add details later to it. There's no pins on it. There's lots of different ways to put pins on. I'll show you a few of them. I bring this up and I can say, look, I have a couple of input pins and some output pins. I just plunk them down like that. If I don't like the size of the box or need it to be larger, I can just go down here and make it larger. Really flexible. Again, when you're kind of just trying to put the logic together and wire things up, it creates a lot of flexibility. I can hit the device here and then do all the pins. So if you had a very large pin device that you wanted to work with, really convenient for that. If I look at the design browser, I can manipulate pins here, decide, I want to remove these for some reason, I can remove those. And I can select a pin here, hold that down. If I want to swap pins, I can swap pins. Okay, so really helpful. To wire up multiple wires, a nice advanced feature here, multiple wires, and I pick these 5 pins, and I want to wire them over here, automatically does that for me. And again, the intelligence of the application, if I move this around, right, it's aware that it's wires, it makes sure that they don't conflict with each other, and does the routing for me to keep that straightened up. Looking real nice. I want to show you one other simple case here. Let me just do a device here that's not very big. And we'll just put a few pins on it, maybe 4. Add pins, 1 or maybe 5. Okay, there's a pin, it's a device, and eventually what you're going to come back to, and you want to assign that apart. And so what I do is I bring up the properties window here, and here's the library field where we can query into the library. And so I do a query here, and it comes back and it says, here's the filters that we're going to look for. We're going to look for parts that have at least 5 pins. I can add more filters to that, and then I just simply go out and do a query. And so it's querying the electrical parts library, and I can sort these column headers to find out what part I might want to look for. This is, I'm showing first the number of cavities. So I can select from this, and I can view more details of this part and see if this is the part that I want, or I can add more filters. And the filters can be added with this button up here, add the filters, and this is the pull-down menu that I'm showing here. You can narrow the search by looking through the descriptions in the electrical parts library or other parameters and properties that you're familiar with. So it's a great way of filtering down and querying into that electrical parts library. And the benefit was we were able to continue our design by using these devices to do the wiring and wiring that all up for us. Okay, I want to show a highway here. This is a nice example. Those of you familiar with buses, for example, you might have a situation like this where you see that we're using a lot of white space because we're got the wires going through the middle of the page. And we can use something called highways if we want to clean that up and have it look a little bit different. So I select a highway here. This is one example of doing this. Again, to me, this is kind of like a bus. Depends on the applications, right, that you use. And now I just simply grab all this, right mouse button, and say, I want to route this information into the highway. And in doing so, that cleaned that up for me. And again, going back to our design browser, right, notice there's a little section in there that has the highways, and it keeps track of all this content for me. And again, I can change the names in the design browser as well. You also might want to do, this would be pretty common, it's like, hey, this wire 100, I really like to unroute that and pull that out. You know, if that's kind of a control or special wire, right, it's easy to read, right, so people can follow, okay, I can see that's the control line for this bus of wires that's going through there. So we can do that. We can even do stacked pins on the fly here. You can take this device, right mouse button, say I want to create a stack. Where do I want to put that? Kind of put a bus there and then a stack if you'd like to have it look that way as well. The other thing you may want to do when these devices get pretty large, let me just show you a real large device back here. Lots of pins on it. There's something called a slice where you could take a slice and break a component up. And now what I'm looking at, I have a component here that's shown as two pieces, right, that logically make one connector. So I could move this to another page, and that's what the lightning bolt sign is here. And I can do that with wires attached and move this circuitry around. So it's really powerful editing tools to be able to do that. Okay, I want to show you an example of ladder diagrams. For those of you that are doing control panel type applications, let me bring up something for you. And I'm going to bring up another project to show you that. So I can go to Project Open. There's a panel design here. And in the project browser, we can have more than one project, so you can toggle back and forth. So this is a different project we're looking at, ANSI machine panel design. Open this up, and now I have 7 sheets that we're looking at here. I'm just going to double click one. Okay, I'm going to leave zoomed out here for this view. I'm going to zoom in a little bit, but I wanted to show you the numbering scheme, the 101 down to 121, 122 to 142. So those of you doing ladder diagrams, you're going to want to be able to set up these title sheets to do this. And what we're looking at is when you place a component in the proper position, the name is inherited by the position. So this fuse, for example, if I moved it to a different position, we want this graphic to be smart enough to rename that part. And that's what you see what happens here with the fuse 103. I can take the same, move it over here, Control V, and when I put that down, right, I get the proper naming convention that I'm looking for the ladder diagrams. So likewise, when we go to sheet 5, open that up, again, we get the same numbering, but everything begins at 501 on up. So this is supported in the symbols library where you create these ANSI standard drawing sheets that you need for your ladder diagram. So I wanted to make sure that I covered that as well. About the design management, I just want to make a little comment about that. Go back to this electrical systems here. We have under the projects here, or files, you can import designs, which are XML files, so we can export designs, we can copy designs, import designs into other projects. So it's real easy to manage this content. And for those of you that are using Team Center, this also integrates with Team Center. So the last thing I want to show you here is the connected mode. And that would be the bidirectional communication with our MCAD environment. So I'm going to just close down this other project. And I'm going to bring up a simple schematic. Okay, now let me just show you this schematic, and then I'm going to go into a split screen. So I just have 2 connectors in this wiring diagram, and I have 14 wires, and the 150 represents the length in millimeters of the particular wire. So I'm going to move this to the split screen, and I'm going to bring up the solid edge environment. And I'm going to bring up an assembly in solid edge that has these 2 connectors placed into the assembly. So the idea is, rather than having to, in MCAD, redraw those wires, put in those properties in the details, we want to read the information from our electrical systems team. So the way we establish this connection is under the electric mode here. Pull down. I say connect. and I'll get a message window, kind of give me the status. Back to our wiring design under workflow, I also say connect. And I'm looking for this green text here that says connected mode has been established with Solid Edge. Let me close the message here. And now I'm ready to actually send the information over to the MCAD environment. And we control what information goes from the wiring design over to MCAD by using what's called harness attributes. So what we do is you grab the electronics that we're interested in, we give it a unique harness attribute. In this case, this has already been assigned harness 1, so I'm just going to go with that. And before I do the bridge out, that's the process that we described to go from wiring design to MCAD. I just check the filter because I could likely have more than one harness filter name, and I would select which ones do I want to bridge out. So I'm just going to go with that one, say bridge out. And then the files are created. I get a report. I'm not going to go through all of this, but just show you how easy it is to do. And now what I get on the MCAD side, I now get a green indication here that there's some wiring data for us. And we can reject this or we can accept it. I'll accept it here. And then here, it's noticing that we have a component with two components with the same name, and I need to know which unique ID goes to which one. So we're simply just going to match these occurrences, and I'm going to pick that occurrence for that one and assign that to that one. And then I'm ready to finish this little wizard. Get all the connectivity information over there. So now we have all the details of the connectivity from the wiring team into the MCAD. And then in this environment, we may do some bundlings of the wires, route it through our assembly, again, making sure we're following all the compliance that we're in the performance that we're looking for. And then we would be interested in sending the wire links back to the electrical team. So let me show you that. But before I do that, the other thing is the cross selection. If you want to cross highlight, right now that's not turned on. So if I select this plug in the wiring design environment, yes, it does toggle or selects with the design view, but I can't tell which connector that is with the MCAD. So as long as our colleagues are on the same network, right, they can be sharing this information visually even though they're speaking on the phone, for example. So in order to enable that in MCAD, we say, look, I want to turn on the cross highlighting. So now when we select a component or a wire, we can agree on what exactly we're talking to. Again, it's helping that communication, building in that efficiency, right, so we can exchange that information. So with this, let me just do a quick routing or bundling of the wires. I'm going to group these wires together. And I'm going to bundle them and route them along this path. Pick that path. Add a little shielding. And then we can finish. So I've actually routed those real quickly. And what we might do, because we have the physical information and size of the wires, we could have the display in 3D a little bit more realistic by turning on the physical conductor characteristics. Right mouse button, same with the wires. Okay, so now we're looking at that view. And then the process again is bridge in. To share the information, we're going to read the information, the links from our MCAD environment with bridge in. And when that's done, you notice now we don't have all these wires at 150 millimeters anymore. They have the real links on there. And I can toggle the cross selection on and off from the MCAD side. So that's really the connected mode, and I wanted to make sure that I touched on that for those of you that are using Solid Edge. But as a reminder, you can use Solid Edge wiring design standalone and independently, right? Doesn't need Solid Edge to run with that. Okay, that's the end of my demo. I'm going to get back into the slides here and give a little summary. So some demo highlights. I wanted to show you how we could use the tool for design management, right? Keep track of your design content, right? All the output formats that you get from that. What's really important in there is the electrical parts library that we can query, right? Look for the symbols, look for the parts. You can search the parts based on parameters that are in the library. Kind of narrow down that search and put that on your schematic. And then, of course, if you don't have symbols, you can use the devices to keep that drawing progress moving forward. It offers styling, so you can implement your company standards. And as you're building your wiring diagram and they get pretty complicated and sophisticated, you have the design rule checker running for you to look for those various errors and warnings and make sure, catch those early, right? Make sure they don't cause problems for you later on. And to optimize your design, whether it's looking at the function of your circuitry, having confidence that what you have designed, is it going to work as you expect it to, or looking at the sizes of the wires or the fuses. Have you selected the right devices? Would there be better options? And you are able to do that by studying that with the ability to simulate in the solid edge wiring design. And there's, in addition to the PDF outputs from both the wiring design and harness design, there's tables and wire lists, etc. So you have everything you need, and it's all generated from the content that's within inside that electrical wiring design application. So if you like what you see, I'd like to encourage you to try it. There's a free 30-day trial on this on-demand training link, and Sarah's going to provide that to you in the chat window, where you can go there and register, and you get 30 days to walk through a tutorial that you run on the cloud. It's a real good way to kind of see how solid edge wiring and harness design works. And also on the Siemens Digital Store, you can buy the product directly. Just go right to that link, and Sarah has that as well. The comment I wanted to make here is that you don't have to buy both solid edge wiring and harness design. That's the product shown on the right-hand side, or the licensing level. You can buy just solid edge wiring design or solid edge harness design separately if you wish. The comment here is that the software you get is the same. There's one download called solid edge wiring and harness design, and that's what you install. So your ability to run these others is dictated by that license.